Mathematics, Analysis and Approaches, Paper 1, Timezone 1, November 2025. This is Section B, question number 9. This is of 14 marks. Section B's questions are generally lengthy. So you can see that in this question, he's asking us to find out the points where the curve has horizontal tangents. And he has not given us the actual function. This is a differentiated function, which means if I integrate this, I'm going to have a cubic equation. So a cubic equation will be of this shape. Generally, it has a wave kind of a shape. And I can see that it will have 1 point of maxima and 1 point of minima. All right. It is not a strict hard and fast rule, but in general, that's how it is. And when he says that the tangents are horizontal to the x-axis, he's basically saying that the slope at these points are equal to 0, which basically means dy by dx is equal to 0. So I'm going to quickly take that question, part A, and then try to solve it. The entire question is dependent on that, finding the local maxima, local minima, and then finding the point of inflection. He has given us a sign diagram for the second derivative also. And then he gives us a condition through which we can actually find the equation itself. All right. There are multiple concepts that we're going to be using in this question. The idea of extremum, the sign diagram, the slope of a tangent, differentiation at a particular point gives us the slope, the idea of concavity, and what is the meaning of stationary and non-stationary point of inflection. Those are the concepts. So I'm just taking the first part, which is the function itself, 3x squared plus 12x minus 15. And for extremum, which means either a maxima or a minima, I have to equate the differentiated function to 0, which is what I have done here. I can see that this equation can be divided by 3. So I'm going to go ahead and do that. I'm going to have x squared plus 4x minus 5 equal to 0. So the factors here are going to be 5 and a 1. So x squared plus 5x minus x minus 5 is equal to 0. I take a x common out, remain with the x minus 5, minus common out, x plus 5 is equal to 0. That gives me x minus 1 into x plus 5 is equal to 0, which means x minus 1 is equal to 0, or x plus 5 is equal to 0. That would simply mean that the value for x is a 1 or the value for x is a minus 5. He has also given us a condition that a is less than b. Please keep that in mind, which basically means that the value for a is minus 5 and the value for b is 1. Great. Find the value for a and b. Now part B. The following diagram shows 3 intervals along the x-axis. The sign diagram is shown here. Let's go ahead and plot the curve itself. So I know that this equation has its 0 at these 2 points. So I can simply draw a parabola like that. Right. You can see that the values of y are all positive here, values of y are negative here, and values of y are positive here. This question doesn't necessarily ask you to do it, but I'm going to make this connection at the end so that you can learn about this and also how to graph the function and the differentiated function and so on and so forth. Okay, let's look at section B. State with reason whether there is a local maximum point or a local minimum point on the graph. Ideally, if based on this particular information, if I had to predict the cubic equation that I'm going to get, I know that the differentiated function or dy by dx, so the slope is positive over here, which means the function is actually going up. And at this point, the function has a negative slope after 5, so it's probably going down, and then after this point the function has a positive slope, so which means it goes up like that. So I can predict that my cubic equation is something like this. So now how do I know that the function has a maximum point or a minimum point? The simple answer is that the differentiation before a is positive and the differentiation after a is negative, which means the function is increasing and then decreasing. Therefore, this point at x equal to -5 will give me a maximum point. And the similar fashion, I can also say that the function is decreasing and then increasing. So f dash of x is negative and then positive, and therefore at this point we will have a local minimum. The second derivative of the function f double dash of x is 0 at x equal to c. Find the value for c. Pretty simple. I'm going to take the equation itself, which is 3x squared plus 12x minus 15. This is the differentiated function. So if I double differentiate, which means I differentiate the function again, I get that. And then for the point of inflection, I'm going to equate that to 0, which would mean that 6x plus 12 is equal to 0. That would mean x is equal to -12 and x is equal to -2. X is equal to -2. Okay, great. So what does it mean at x equal to -2? Obviously, at x equal to -2, I don't have a maxima or a minima. I'm guessing if f double dash of x is 0, which is, understand this, what is f double dash of x? F double dash of x is the behavior of f dash of x. F dash of x is the behavior of f of x. So when I say behavior, I'm talking about the tangent. This is the tangent equation of f of x. This is the tangent equation of f double dash of f dash of x. So when I say f double dash of x is 0, I'm talking about this point. Alright? Which means the differentiated function has a minimum at that point. So what does it mean for the actual function? For the actual function, it would mean that this is the point where the concavity is changing. So this is concave downwards, concave upwards. As in when the function is moving from concave downwards, it's going to make a change to become a concave upwards. The point where it is making that change, this point, is the point of inflection, and this is known as a non-stationary point of inflection. So when I go back here, I found the value for c, which is a -2. The following diagram shows two intervals. You can see that he is given negative and positive. So what does that mean? The concave downwards is changing to concave upwards, and that's your c. State with reason whether there is a point of inflection on the graph at c. Yes, there is a point of inflection at the point c, which is basically the point of inflection here, and that is happening at the point, a point x equal to -2. What you need to write is the double differentiation is negative and then positive here. That's all you need to write. Given that f of -2 is equal to 36, find f of x. So I know that f dash of x is equal to 3x squared plus 12x minus 15. If I integrate this, I'll get the actual function. So the integration of this function is that plus the constant c, which is simply going to be equal to x cubed plus 6x squared minus 15x plus the constant c. Now he says f of -2 is equal to how much? 36. I'm going to use this to get the value for c. So 36 is equal to -2 cubed plus 6 into -2 square minus 15 into -2 plus the constant c. So 36 is going to be equal to -8 plus 24 plus 30 plus c. So how much is this going to be equal to? 36 is going to be equal to, this is going to be a 16. 30 plus 16 is a 46. So c is a -10. So the actual equation will be f of x is equal to x cubed plus 6x squared minus 15x minus 10. This, as we know, is a non-calculator paper. However, I would like to graph the equations for you and show you how it looks. Okay, it's going to be interesting. You can see here I've actually drawn the actual function itself. So I know that at this particular point there is a maximum, and you can see that the x values are -5 over there, which is what we got, and the minimum is happening at x equal to 1, which is also what we got. We'll quickly look at the differentiated function. This is the differentiated function. You can see that it's a -5 and a 1. So in comparison, let's look at the actual function itself. So you can see that x equal to -5 is here. The differentiated function is a 0. Again, at x equal to 1, the differentiated function is a 0. So at that point, we get that. And you can see that the behavior of the dy by dx is positive here, which means that the function is increasing. Dy by dx is negative, which means the function is decreasing from here to here, and then again at 0, and then this is the minimum point, and then dy by dx is positive, which means the function is increasing. Let's look at f double dash of x, and that with respect to the actual function itself. First, we'll compare it with the differentiated function, and then we'll go to the actual function. So what is this saying? At this point, d square by dx square is always is 0, which means this is the point where the point of the dy by dx is having a minimum point. So dy by dx until this point is negative. D square by dx square until this point is negative, and therefore you can see that this function is decreasing, and after this point it is positive, and therefore this function is increasing. Now when I compare this to the actual function, that's how it's going to be. Double differentiation at this point gives me a point of inflection, and this is a non-stationary point of inflection. So I'm going to draw a line x equal to 2, -2, and you can see that this is the point at which the concavity of the function is changing. So from here to here it's concave downwards, and at this point it starts to become concave upwards. So concave downwards, d square by dx square is negative. Concave upwards, d square by dx square is positive. Right. Well, that's your explanation for this question. I hope you understood and learned something about concavity through this question. Though the idea of concavity which I explained was not necessary for this question, it's just an added information. I thought I will share it with you because you're gonna encounter this at multiple questions. Okay. That's it for this video. Thank you.